Bismillahirrahmanirrahim. Welcome to the lecture 3. I hope that you all have done your homework and you are very clear in your concepts because you haven't asked any question in the group. So there are two meanings of no questioning. One that you have understood everything, and the second meaning is you haven't understand anything. So I want to stay positive and I hope that you all understood the previous lectures and you have done your homework. So today the objective of today's class is after this class you will be able to understand the limitations of propositional logics. In last classes we have discussed about the propositional logics, and in today's class we will move one step forward and we will discuss about what are the limitations of these propositional logics, and then the solutions for these limitations. We will also see the solution of these limitations. Then we will move to a new topic, the predicate logics, and we will study about the difference between the propositional logic and predicate logics. Then compound statements in predicate logics. We have done some homework on propositional logic and compound statements. So today we will again do the same practice but in different context. And then the last is quantified statements. So these are some new topics for you and new concepts, and I hope that you will understand this. And at very first class, I told all of you that every concept is linked with the new concept. So if you clear your basics, you can understand it very easily. So you already know about this topic, the propositional logic. Let me just review it. The definition is: the proposition is a statement that is either true or false. So we have practiced so many examples of propositional logics. If any statement has the true or false truth value, then we can say that it is a propositional logic or it is a proposition. So here are some examples which we have discussed earlier. The pit is located in the Oakland section of Pittsburgh. 5 plus 2 is equal to 8. So we can guess the truth value of these propositions. Some are false and some are true. Not a proposition like how are you. So you cannot say that it is a proposition like you cannot guess the true or false value out of it. X plus 5 is equal to 3. So we don't know about the value of x, so we cannot identify it, or we cannot guess the truth value of this statement. Now we discuss about the limitations of propositional logic. That there are some limitations. In last lectures we just discussed about the concept of propositional logic. We have discussed about some examples, and then we use that truth table to construct a compound truth table or compound statements by using some connectives like and, or, exclusive, or, so on. So propositional logic, the word is described in terms of elementary propositions and their logical combinations. As we know that the propositions, we have used the translation to translate or transform the statements into logics. But there are some objects, the statements depend on some objects and their properties and relationship, which was not represented in the propositional logic. Like John is a UPITT student, so John is our object and RUPITT student is a property, which is not represented in the propositional logic, but every statement has some properties. So the first limitation is that statements that must be repeated for many objects. Like if there is a statement and that statement we can repeat for many objects, then we can say that this is the limitation of propositional logic, because in propositional logic, whenever we have such kind of statements, we just call it's not a proposition. Like if there is if we see some variable in the statement, then we say this is not proposition, because we don't know about the value of the variable. So for example, if John is a CS UP IIT graduate, then John has passed CS 441. So from this statement can be repeated for many students of CS UP IIT graduates. Like in your class, if I say one statement for one student, then that statement can be repeated for the whole class. So what is the more natural solution to express the above knowledge? Now we have this scenario that how we can represent this statement, and what is the solution. So for solution for this limitation is to make a statement with variables. And you know that when we used variable in propositional logic, we directly concluded that this is not a proposition. But here we have seen a new thing, that we can represent such statements with variables. If X is a CS UP IIT graduate, then X has passed CS. So we can represent the objects with the variables. And later on we will see that how we use these variables to make it a proposition. The second limitation is the statement that define the property of the group of objects. Like there are some the properties that is of group of objects, like for example, all new cars must be registered. So there could be many cars which need to be registered. So it represent or it categorize into a group. Some of the CS graduates graduate with honors. So this is again the property of the group of objects. So this is the limitation of propositional logics, because in propositional logics we haven't seen such scenarios, which was so that's why it is called a limitation. So solution for this is make statements with quantifiers. So this is a new thing which you have to remember. The quantifiers we are using to represent the properties of the group of objects. So there are two kind of quantifiers, the universal quantifiers and existential quantifiers. So what are the universal quantifiers? As the word is already expressing its meaning, universal means for all. The property is satisfied by all members of the group. So this is very easy to understand. The universal means for all. So if any property is true for all the members of the group, then we can say that it's a universal property. And the existential quantifies is at least one member of the group satisfy the property. So if there is a chance, like if I say in your class that some students got A grade and the rest of in B and C, so there is a possibility of few students got grade A while the other are in B and C. So this is like, but there must be at least, if I say that A grade, if I just want to express the grades A grade, then there must be at least one member of your class satisfy this property. The predicate logics, this is a new concept, a new word, new topic for you. Basically the predicate logic is the remedy, is the limitation of propositional logic. So this is basically the provides us the way out or the solution for the limitations of propositional logics. So first is explicitly model objects in their properties, and it allows to make statements with variables and quantify them. So there are some like building blocks for the predicate logic, that is the constant. For example, name or name of the place or any uh, constant value. When the variables represents objects of specific type defined by the universe of discourse. So we use variables to define the universe of discourse. Example x, y, we use universe of discourse can be people, students and numbers. Later we see some more examples, and then you can better understand about the predicate logics and how we convert the statements into the propositional logics. So predicate basically it can be of over one, two or many variables or constants to represent properties or relations among the objects. So it basically represents the relation and properties which was ignored in propositional logics. Now we see some examples of predicates. The predicate basically represent properties or relations among objects. A predicate P of x assigns a value true or false to each x depending on whether the property holds or not for x. So this is how we can read this predicate in such a way like P of x assigns a value true or false to each x depending on whether the property holds or not for the x. The assignment is best viewed as a big table with the variable x substituted for objects from the universe of discourse. What it means? It means that if we want to show the properties of the group of people, like assume that student of x where the universe of discourse are people. So the student John, if John is student, then we can say it's true. Student n is true if n is a student, or student Jane is false if student is not. So these basically it represents the properties of the objects. Now we see some more examples, like assume predicate P of x that represents a statement x is a prime number. So if x is a prime number, then what are the truth values of these values? P of 2 is true, P of 3 is true, P of 4 is false because it's not a prime number. So it predicates represents the properties of each items in a group. So all statements P of 2, P of 3, P of 4, 5, 6, 7 are propositions. But if we say P of x is a proposition, if I ask that P of x is a proposition, then we will directly say no, because we don't know about the value of x. But when we put the value of x, then we can say that these are the propositions. So yeah. Now the predicates can have more arguments which represent the relations between objects. For example, that older, John Peter denotes that John is older than Peter. So this is a proposition because it is either true or false. So we can say that there is more arguments in the same statement. Older x, y, x is older than y, not a proposition. Why? Because after that substitution will become 1, because we don't know about x and y, the value of x and y. When we put the value, then it convert into a propositions. Now we see another example. Let q of x, y denotes x plus y greater than y. So if I ask you the question q of x, y is a proposition, then the answer is no. Why? Because there is no value. When we put the value, then we can calculate and we can say that it's true or false. Then we can convert it into propositions. Now the compound statements in predicate logic, compound statements are obtained via logical connectives. So this is the logical connectives you already know. and we have used in the previous lectures and previous concepts, students and student Jane. So the translate when we translate into a statement, both N and Jane are students. The proposition is yes, and the second is the Sena is a country or a river. So this is again a proposition. But the last example, C as measure of x implies student of x. So if we translate into a statement, if x is a CS measure, then x is a student. But we say it's not a proposition because we don't know about the x. So important to know about the predicate is P of x is not a proposition since there are more objects it can be applied to. Like if we say that P of x is a proposition, we say no. But still there is a chance if we know the value of x, then we can apply it and we can convert into a propositional logic. So the difference here is predicate logics. What predicate logics is doing is to allows us to explicitly manipulate and substitute for the objects. The first thing. Second thing is predicate logic permits quantified sentences where variables are substituted for statements about a group of objects. Second, predicate logic permits quantified sentences where variables are substituted for the statements about the group of objects. So the quantified statements, if we see the quantified statements, predicate logics let us to make the statements about a group of objects. To do this, we are special quantified expressions. We have two different kind of quantified statements. One is universal and the other is existential. We already explained about the universal as the universal words showing itself, that is for all, and the existential that there exist some values for the some people. So the universal quantifier, we define it in such a way the universal quantification of P of x is the proposition. So we can say that if all the values of some group or the properties of some group is true, then we can say that it is a universal quantifier. So we represent it by turned A symbol, and we can find out the property of the group. So we just see one example from this slide. Let P of x denote x greater than x minus 1. So what is the truth value of for all of x, P of x? So we assume here that x is a real number. So to answer this question, that every number x is greater than itself. So if you put any value for x, you can conclude that it's true in all the conditions. So we can represent in such a way like all of x, P of x is true. The universal quantifier basically quantification converts a propositional function into a proposition by binding a variable to set of values from the universal discourse. So this it helps us to convert the propositional function into propositions. Like if let P of x denote x is greater than x minus 1. If I ask question like is P of x a proposition, then the answer is no. But many possible substitution. So when we put some value in it, or we use quantifiers, then we can say that it is a proposition. Universally quantified statements are predicates lets us to make statements about group of objects. Universally quantified statements like CS measure x implies student of x. If this is in proposition logic, it's not a proposition. But when we use the quantifiers, there exists CS measure implies student of x. Then it converts into a proposition. Then the second quantifier is existential, and the existential quantification of P of x is the proposition. There exists an element in the domain or the universe of this code such that p of x is true. So in this way we can say that not all but at least one value is true for this scenario. So from this example we can say that let t of x denotes x greater than 5 and x is from the real members. What is the truth value of there exists x t of x? So we can say that there are some values which are true but not all. So we use here the existential of x t of x. Existential quantified statements about group of objects. So we use these quantifiers to make statements for group of objects. The quantified statements about group of objects, these are the examples of using the there exist and using with the logical connectives like and or. The summary of this quantified statements, this is to remember that in what cases or in what scenarios we can say that these values are true. So for all of x p of x, like universal quantifier is true when there is an x where p of x is false. True when p of x true for all of x, like if all the value of the p of x is true, then universal quantifier is of p of x is true, and false if even one value is false, then this would be the false, and this is the opposite to their existential. This is all about today's lecture, and I hope you will practice it and you may ask any question in the group, and I would answer in the same group. Thank you.